Hello there. Today we're going to extend our work on Pythagoras. Yesterday we were looking at mixed examples where you're having to calculate the long side sometimes and the short side other times. Today we're going to apply that to real life situations. So we'll have a series of examples showing you the kind of questions that you could get asked and the kind of situations that you can apply Pythagoras to. So the first one that we've got here is a classic, the ladder leaning against the wall. And we're asked to work out how long the ladder is. So I'm going to call that x, because that's the value we don't know. The distance from the wall to the bottom of the ladder here is 2 meters. We call that A. And the distance up the wall to the top of the ladder is 4.8 meters. I'm going to call that B. So, because we are looking at finding the hypotenuse, because that is opposite our right angle, remember we did that, that means that we can use the standard formula. So we're going to have x squared is equal to a squared plus b squared. And then we can substitute in our values for a and b. So x squared equals 2 squared plus 4.8 squared. We work that out. So 2 squared is 4. 4.8 squared, when you put that in your calculator, it gives you 23.04. Add the two together. 27.04. Now remember, that is us calculating x squared. So x squared is equal to all these things. But we're trying to find the length x, so we have to take the square root. So the square root of 27.04, because the square root of x squared is x, so we find the square root of 27.04, and that comes out at 5.2 meters. So our ladder is 5.2 meters long. Okay, go on to another example. So again, we've got a ladder, but this time we're told the length of the ladder, and we're told how far away from the bottom of the ladder, bottom of the wall the ladder is. So we have to work out how high up we can reach with that ladder. So just check where our hypotenuse is. Again, opposite our right angle. So this one here is C, our hypotenuse. And as I said before, it doesn't matter which way around you label these two up. They're both short sides. What will be important is looking at the part we're trying to find. So I'm going to call that A and that B. But as I said before, it doesn't matter which way around they go. What's important when we're trying to find the short side was the bit we're looking for needs to be on its own. So B squared on its own, and then it's always the longest side squared, subtract the other short side squared. C squared minus A squared, A squared. And then we can substitute in the values that we have. So B on our triangle is the height h, so I'll just write h squared. C is 2.5 meters, so that's 2.5 squared, and A is 1.5, so that is 1.5 squared. We work these values out. 2.5 squared is 6.25, 1.5 squared is 2.25, subtract the 2, gives us 4. Remember, that is h squared that we've worked out. So we need to take the square root. The square root of h squared is h. Square root of 4 is 2. So this ladder reaches 2 meters up the wall when the base is 1.5 meters away. Okay? Let's look at another possible situation you could get asked about. So this is another kind of classic Pythagoras type question. The length of a farmer's rectangular field is 75 meters and it's 50 meters wide. So this question is asking you about a rectangular field. But you can get asked all sorts of different things, and you can apply it to all sorts of different rectangles. It could be a window, a doorway, it could be a flag, it could be anything. Anything that's rectangular shaped, you can apply this process to. So let's pull the rest of the information from our statement, because our picture doesn't actually have any numbers on it. So how long is the path across the field, across the diagonal of the field? So we need to find out the length of this path. So I'm going to call that C. It tells us the field is 75 metres long. So this is 75 metres. And 50 metres wide. We know because we're told this is rectangular that this is a right angle. So now we have a right angled triangle going down here, along, and then the diagonal. And now that we have a right angled triangle, we can apply Pythagoras. The length we're looking for, the diagonal path, is opposite the right angle, so that is the hypotenuse. So that means that we can use our standard formula for this one. So I'll call one side A and one side B, and then we can have C squared equals A squared plus B squared. And that's the standard formula you guys have been using. Then we substitute in our values. 50 squared plus 75 squared. So we're going to end up with some big numbers here. 2,500 and 5,625. Now you're not expected to do these on paper, just use your calculator, type in 50 squared, and it will give you the answer for that one. And as I've said before, add these two together, 8,125. As I've said before, if you're able to type in this line here in your calculator and then just press equals, you can miss this line out here. You don't have to write that part in. If you type that in your calculator, press equals, it's just going to tell you 8,125. If you're using a calculator on your phone or something that's not capable of typing all this in one go, then you'll need to do it in stages and write in that extra line of working. And as we said before, these are all C squared. So now we have to take the square root to find what C is. So the square root of 8,125. Put that into the calculator, and it's going to tell you that it is 90.138, and then loads of other numbers, which I'm going to round to 90.14 metres. That's just rounded that to 2 decimal places. The question didn't tell me how many decimal places, so I've just picked 2. Normally the question will tell you. Okay, so I'll just write that to 2 decimal places. That's why we write in this line here, which tells the person that's looking at it. There's a lot more information here, but we're going to round that down to here because these small place values don't really change it very much. Okay, another kind of question you could get asked. We have a telephone pole and a wire supporting it to stop it falling over. But this is another question where it's not actually giving you all the information straight on the diagram. You have to start pulling it from the story. So the support wire is 4.5 metres long. So on our diagram, find the support wire and put in the length. And then it says it's fixed to the ground 2.5 metres from the foot of the telegraph pole. So that means that the end of the wire is 2.5 metres away from the bottom. So this bit along the bottom here is 2.5 metres. And it says calculate the height of the pole. So the height of the pole is going to be the length here. We can call that h. Now, when you get a diagram, if it's beginning to look like it's a bit confusing, what you can do is you can pull out the triangle. So there's nothing wrong with just having a little sketch and drawing a little triangle. That's particularly useful if the triangle is on its side or looks like it's upside down. It means that you can write it out the way it is and then have the confidence that you've laid things on the right place. So I'll pull across our measurements. H, 4.5 metres, 2.5 metres. Okay, so we are not looking for the hypotenuse in this case because the hypotenuse we have a value for, which means we're going to be using our formula for finding the short side. So that is C. This one will be B. So our formula is going to be B squared is equal to C squared minus A squared for this one, because we're making sure that we have the part we're looking for on its own, so this length here, and then we have the longest side first minus the other short side, squares of both of those. So it's always the longest side that goes first when we're subtracting. We substitute our values in, so the length B is H, C is 4.5, A is 2.5. Put that into your calculator. 4.5 squared is 20.25 minus 6.25, which equals 14. But again, that is H squared that we've worked out. H equals the square root of 14. And your calculator will tell you that that is 3.741, and then lots of other decimal places. I'm going to round that to 1 decimal place this time. Again, the question doesn't tell us, so I'm just picking 1. So the 4 rounds down, so it stays as 3.7 metres to 1 decimal place. Okay. Another kind of situation where you often can apply Pythagoras theorem is when you have other types of triangles, so isosceles triangles or equilateral triangles, triangles where there's a bit of symmetry about them. You can usually pull out a right-angled triangle from within them. So we have the whole triangle, the red part here of the sign goes all the way around the outside. And because it's an isosceles triangle, that means it's symmetrical. So the right-hand side here, with the right-hand side of the dotted line, and the left-hand side of the dotted line, they're both the same. And it means that at the bottom here, this is a right angle. Right angle on that side as well, because they're symmetrical. Okay, so now that we have that, we can pull out a little right angle triangle. So I'm just going to draw it to the side because there's quite a lot going on in this diagram, and I'm going to have to change some of the values. So, draw down. Okay, so we have a right angle triangle. Mostly looks right angled, a little bit squint there, but you know what I mean. Okay, so now we start pulling information from this diagram here. So we know the diagonal down is 48 centimetres. Now the base, this is where you have to be a little bit careful, because we are given the measurement for the whole length of the base of this triangle. But this dotted line, which makes up this line here of our right angle triangle, meets in the middle because it's an isosceles triangle and they're symmetrical. That means that this base is half of the 44. So that is 22 centimetres. And we're asked for the height of the sign, so we'll just use h because it's the height. Now this part here that we've pulled out, that's all the information we need to be able to work out the height. And by drawing a little diagram at the side, or in your jotter, it means that you can kind of get rid of the other things that are in here that might distract you. And then just have all the information that you're looking for. So opposite the right angle means that this length here, 48 centimetres, that is our hypotenuse. So that's going to be C. And as we said before, doesn't matter which way round we line these up, we label them up. So I'm going to call the side one A and the bottom one B. Now, again, when we are setting up our equation, our formula, we are going to have the part that we're looking for, which is this side here, H, so the part A, that has to be on its own. And that equals the longest side minus the remaining short side, so B. So A squared is equal to C squared minus B squared. So always the part you're looking for is equal to the longest side, the hypotenuse, minus the other short side. Substitute in. H squared equals 48 squared minus 22 squared. You put them into your calculator, you get some pretty big numbers. 2,304 for 48 squared minus 484. Do that subtraction and it comes out at 1,820, and that is H squared. So to find H, we need to take the square root of both sides. The square root of 1,820 is 42.661, and then lots of other numbers in the other decimal places. I'm going to round that to one decimal place. 42.7. The 6 tells us that we need to round this 6 up. So 42.7 centimetres to one decimal place. Okay, I'm going to have one final example. It's a wee bit more complex. So in this one, Khalid wants to cover the roof of his shed with felt. So that is this sort of greeny colour bit at the top here. That's what we're going to try and work out. We need to calculate the length of the sloping edge of the roof of his garden shed. So that's part A. We need to work out the sloping edge. Then we need to use that information to calculate the area of the roof. And then we need to work out whether Khalid can afford to buy the felt for it. The roof felt costs £5 per square metre and he has £35 to spend. So we need to work out the area to be able to decide whether or not he can afford that. Okay. So we're going to have to do a little diagram here just to pull the correct information out. So I'm just going to draw that underneath because it's pretty complex looking at this first diagram. So what I'm going to do here is I'm going to draw this end bit here. It's the wrong thing. I'm going to draw this end panel. Okay, so it's in red, that's alright. So we have a trapezium shape. The shed is 2.5 metres tall at the back, 1.75 metres along the bottom. Just going to clear that out because that's getting in my way now. So 2.5 metres along the back. So this is our back here, 2.5. Just going to rewrite that, didn't look very nice. 2.5 metres. Our base, 1.75 metres. Okay, now we have to be a little bit careful here. We're looking for this length here. I'll put it in red side here. We're looking for this length here. Now if you have a think about the shape of the shed, the height here is the same as the height here because that's at the same side of that wall. So this red bit that we're looking for is 2 metres. Okay. Okay, now the fun bit comes. We still don't have a right angle triangle. So let's have a think about what we do have. We have a trapezium, which tells us that this line here and this line here are parallel. That means that if we draw a line straight across here, it's at 90 degrees here, 90 degrees here. That gives us a rectangle because of the shape of the shed, which means that this part here is going to be a right angled triangle. So what we're actually looking for is this part at the top, this little triangle here, because we're trying to find out the length of this sloping side to tell us the length of the green sloping roof. So I'm going to call the sloping roof S because it's a slope. That is this length here on the diagram. Okay, still don't have quite all the information that we need to be able to do everything. This length here, because this is all right angles, that's going to be 1.75 metres, same as this one at the bottom. Now this bit at the side here, if this whole distance is 2.5 metres and this is 2 metres, then this side here is going to be the same as that one, which leaves us 2.5 minus 2, 0.5 for this length here. Just to make it clearer, I'm just going to draw that triangle out again at the side. This is our sloping roof. Slope S, base of 1.75 metres, and a height of 2.5 minus 2, so 0.5 metres. Doesn't really look like a 5, does it? .5 metres. Okay, so what are we trying to work out? Try to work out S, which is opposite our right angle. So we'll be able to use our standard formula for that one. So call one side A, one side B, one side C. C squared is equal to A squared plus B squared. We can substitute in all our values. So C, the hypotenuse, is the sloping length S that we're trying to find. A is 1.75 metres. And B is 0.5 metres. These should be squared. Okay, now we're getting there. We can put these into our calculator, and that comes out at 3.0625 plus 0.25. Add the two of them together, 3.3125. So that is S squared. So we want the slope and length, so we have to take square root of 3.3125, and that comes out at 1.820, and then lots of other decimal places, and I'm going to round that to 1.82. 1.82 metres, and that is our sloping length S. Okay, so that is the answer to part A. Because part A asked us to calculate the length of the sloping edge of the roof of the garden shed. So that's part A. The answer for that is 1.82 metres. Okay, let's have a look at part B now. So calculate the area of the sloping roof. So we have a rectangular shaped roof along the top here. We know the length of it is 4 metres and the breadth is 1.82 metres. We just worked that out. Okay, so the area is the length times the breadth. The length for the diagram up here is 4 metres, and we just worked out the breadth of the rectangle is this line at the top here, S, 1.82 metres. Multiply them together, and it comes out at 7.28 metres squared. Remember, it's metres squared because it's an area. Okay, so that is the answer to part B. Now, the point of doing all this is to first Khalid to figure out whether or not he can afford to buy the felt for his roof. So the roof felt costs £5 per square metre. So if it's £5 per square metre and we have 7.28 metres, the total cost, this is for part C, so the total cost is going to be his £5 per square metre times the number of square metres we have, so 7.28. And that comes out at £36.40. So that's has got a value for the cost of the felt for the roof. Now you have to go back to the question. So it says if Khalid has £35 to spend on the roof, does he have enough money to pay for the felt? So us working out the price of the felt doesn't actually answer the question. So £36.40 is more than £35, so no, he does not have enough. Doesn't have enough money. He is £1.40 short. Okay, so on a question like this, you can see the applications and the kind of things that you can do. So you could argue that if you've got the shed in your garden, you could just go out with a measuring tape and measure length S. But the problem you've got is that you wouldn't normally buy the felt once the shed's already in your garden. You would normally buy it when you're buying the shed, and then you're often going to be looking online, and you'll only get the measurements that is given you in the diagram here. It won't normally tell you the slope and length of the roof. So if you want to work that out and have felt to make sure that your newly built shed is all waterproof, which is the point of the shed, keep everything clean and dry, then you're going to need to be able to work it out in advance. So that is one of the applications that you could use for Pythagoras. Okay, bear that in mind when you're having a look at today's exercise. Thank you.